So here's an example of the typical data science workflow that we've seen in many cases. Like typically, you would begin by getting the business requirements from the consumer of your machine learning model. You know, that could be, for instance, you want to build a model that makes sales forecasts, or you might want to make a predictive maintenance model that predicts failures on a factory floor. So you can like gather the requirements, what is the metric you're trying to satisfy, and then just like start looking into the data. Where you want to get access to the data and then understand it. And then typically what you need to do is somehow turn the raw data into features that you can then use in the machine learning model. So if it's numerical data, you might want to scale or normalize your data. If it's text, you might want to do something like breaking it into n-grams or something like that. Basically make it into a rectangle of numbers that you can then pass into a machine learning model that you train. And then you train your model, you start getting results, and then you want to validate this model against data that you set aside. And finally, if you get good enough results, that the model meets the business requirements, then you can productionalize it. And notice that this is a highly iterative process. Typically, you would go back and forth these different stages. You might want to get more data. You might try different sets of features, different classes of models, and so on. So the Jupyter notebooks are really useful here because they let you encapsulate this workflow into a unit that you can rapidly iterate upon. You can go from cell to cell, try different things, and so on. And you can also add visualization and explanatory content, so you have a better sense of like what you did when it then comes time to share your notebook with collaborators or present the results to the business stakeholders. But there's a couple of challenges with this workflow that you may run into. Like first of all, it's like how do I scale my compute for data wrangling? You might have a terabyte of data that you want to process on Apache Spark cluster. You might be training a deep learning model for which you require a GPU-enabled machine. And if you're just doing some lightweight exploratory work, you might just want to have some very easily managed compute that doesn't require much setup. And also another problem is like how do I keep track of the different artifacts that got created during this process? This could include trained models. This could include metrics I get from the validation, or like different parameters I used during the training of the model, and also things like visualizations. And more to the point, how do you kind of actually establish an audit trail across these artifacts? Let's say I find there's a data quality issues in one of the features I used to train my model. Okay, how do I now find the production models that use this feature and fix the issue? And finally, how do I deploy my model to production? Like how do I take the dependencies of my model, different libraries I use, different runtime environments, and encapsulate them into a unit that reproduces the results of my model when it's deployed to a production system. And let's say, for example, you're deploying your model as a web service endpoint. As a data scientist, you probably don't want to spend time doing things like implementing routing logic or load balancing or elasticity of your web service. You rather focus on the earlier parts of the workflow, training better models, building better features. So in this talk, I'll discuss ways we've addressed these problems within our team. So first a brief overview of like what are the notebook offerings on Microsoft Azure Cloud for data scientists. There's basically three primary ways you can use notebooks as a data scientist. There's Azure notebooks, notebooks to data science virtual machine or deep learning virtual machine, and then when we go into the really heavy computer, Apache Spark on HD Insight or on Azure Databricks Preview. And to kind of like tie these different computes together, we also have the Azure Machine Learning services, which enable you to use Jupyter notebooks with project management, run history tracking, and model management features. So let me talk in a bit more depth about each of these different environments. So Azure Notebooks first. So Microsoft Azure Notebooks, notebooks.azure.com, and this is really a managed service where you can view notebooks. There's a library of notebooks. Let's take a peek here. Let's get started. See where we get. There's lots of example notebooks that you can use as a starting point for your data science explorations. Let's pick one. Let's pick Discover Sentiment in Tweets. We can view this right here in the browser, like you would expect for a notebook. But what we can also do here is that if I signed in here, I could actually run this notebook in a containerized environment. I can also do changes to this notebook, clone it to my own personal library, or I can share this notebook. And you can actually find quite a lot of content here. There's actually an entire data science course implemented in a form of a library of notebooks on Microsoft Azure. But let's say I'm done with this lightweight exploration, and I need some more substantial compute. What would I do? So the next step up is the data science virtual machine or deep learning virtual machine. So this is a template of a virtual machine which comes with the Jupyter Hub pre-installed, so you can access notebooks that way. And kind of like an advantage of this now is that you can choose the VM size, the virtual machine size, to match your needs. You can pick a small VM, large VM. You can select how many CPU cores you need, and you can choose a GPU-enabled VM. And another benefit of the DSVM is that it comes with many of the popular libraries pre-installed, like the usual ones, scikit-learn, as well as deep learning libraries like TensorFlow, Caffe, CNTK, MXNet, and others. And this is really quite useful because like in my own work, I've gotten into habit that if I need compute to do a data science project, I just spin up a data science virtual machine, and I get everything I need in 10 or 15 minutes, as opposed to spending a lot of time configuring my environment starting from a clean VM. And also there's a specialized kernels for different purposes, like a Apache Spark R or Scala Spark, and for Microsoft R Server. And we've actually discovered that many people use a single VM to do Spark compute, and the main reason for that is that you use it as kind of like an out-of-core compute engine for large data sets where you get the guarantees of the Spark RDDs. And then typically this approach, using DSVM satisfies most use cases, because the VM scale up quite big. Like nowadays you can get a VM with hundreds of gigabytes of RAM. But if you really need big compute, then the next step up is the Apache Spark on the HD Insight, which is a managed open source analytics service, and you can do scalable in-memory data processing over a cluster that you can scale up, and you can process very large data sets, several terabytes or more. And you can use the typical Spark Spark kernels, the PySpark, Scala, or Spark SQL to the Jupyter notebooks. So that sort of like gives a brief overview of the different compute options. So now let's talk about the machine learning services and Jupyter notebooks. So this really gives you a capability of build and manage machine learning models from your Jupyter notebooks. You can do things like log experimentation details, model parameters, metrics for model validation. Use the different compute targets that I mentioned, local or remote VMs, GPU-enabled VMs, or Spark clusters. You can save and keep track of your trained models, and you can deploy models to production as Docker images on a Kubernetes cluster. And the way to get started with this is that you install our client components. Nowadays it's through the Azure Machine Learning Workbench. You go to a command line and run AZML notebook start, and you end up with the notebook which has these wonderful features available. And let me start with the sort of like a baby example of how you interface with these services from Python code. I'm going to use the iris classification of the iris flower dataset as an example. It's really a toy example, and with any reasonable machine learning library, you can get 100% classification accuracy with no effort. But it's really a good vehicle to show how these APIs work without getting into the weeds of the domain-specific machine learning code. So let's see if this opens. Here we go. Looks like it's dropping the presentation when I do the switch. So here we go. We have a whole collection actually of these samples. If you go to the Azure, and there's an Azure GitHub repo, and look for machine learning samples, and there's a whole set of these. So let's scroll up. So we are using scikit-learn and a logistic regression model to predict the class of a species of an iris flower out of the three choices: Iris setosa, Iris virginica, and Iris versicolor. And kind of like first thing that you might notice here is that we import something called AzureML logging, and we initialize something called a logger, run logger, get AzureML logger. So what does this do? So basically, what we've done is we've started this run through our launcher. We are now in a scope of an Azure Machine Learning run, and now we can log different things that happen during this run. These things can be, for instance, instance parameters that we use in our machine learning model. So what we do here is we get the data, we split it into train and test sets randomly, and then we start actually training the machine learning model, the logistic regression model. But before we do that, we actually log a parameter to that model, the regularization rate, that sort of like controls sort of like the bias versus variance of this particular class of models. So, and you can actually, and this is actually quite useful, because let's say today I found a particular value of this parameter that gives really good results. Then a week goes by, I come to this model again, and now I've made some other changes. I've completely forgotten what I did a week ago. So now what I can do is just go look at the history of this run. I can query the history of my runs against this particular parameter, and get a view of what were the values I used in different runs. So I go ahead, train the model, and I evaluate its accuracy, and I log the metric. So now I have a pair of, okay, the parameter I used, and the accuracy I got. So now I can cross-reference, the runs against the metric. I can log other metrics that are useful for machine learning purposes, precision, recall, thresholds. And finally, let's say I'm happy with this model, and I want to now go and take it to the production, or sort of like export this model somehow that I can deploy it to production. What I can now do is I can save this model as a pickle file and write it to a folder called outputs. And this folder is special when you're running under Azure Machine Learning, because our client is looking at this folder, and whenever you put something there, it's a signal that, okay, this file is important. I'm going to promote it into an asset of my project. So now it's available for anyone who has access to this project and can also be queried through the run history. So now I actually have this triplet of the model and the accuracy and the parameter that was used in training this model. And now I can do many useful things. I can, for instance, search for the model that had the best accuracy, go back to the run from where it was trained, and see what I did there. I can also do other things like save other artifacts that happen during the training. I can, for instance, take an AUC ROC plot of my model, or like say a scatter plot of my data, or some other metrics of my data, and I can save them into the run history, and that way I get sort of like a better view of what I've been doing. And so that's like the simple baby example of using the Azure Machine Learning with the Iris dataset. Now let's look into a bit more substantial problem using Jupyter notebooks to predict, to do energy demand time series forecasting. So the problem that we are trying to solve here is what are the demands on the power grid given features such as weather data and the historical energy consumption. And this could be useful if you are utilities company and you want to plan for capacity of your electricity grid. And we notice again, like here, in the first we do usual things: import usual libraries, pandas, numpy, scipy, matplotlib. But then on the next we do something interesting again. Like we import this, we import the logger. So we can, from the notebook, we can again log different properties we want to keep track of from this run. We can log simple messages or metrics like I showed earlier. The interesting here now is that a run of like an execution of a Jupyter kernel constitutes a run, and an execution of a notebook cell constitutes a child run. So I can actually stitch together the lineage of what cells I executed, go back and view the more detailed run history at the cell level. So I'm not going to spend too much time on the details of this notebook. What we do is we use typical data wrangling techniques for the time series data. We use the pandas library to join the historical energy demand data and the weather data. We plot the power demand. Then we do typical operations you would do on time series. Then this is kind of interesting. We can explore the data in our notebook, and we can see the demand distribution, the hourly demand, temperature distribution, and then we can. This is this is a nice plot, the energy demand versus the temperature. So we can see that when the temperature is very cold, the demand goes up a bit, but then when the temperature goes up, then the energy demand increases, and increases a lot, because air conditioning is a very, very power hungry kind of thing. And we can view other features of this data set. Then we go ahead and we train a model. Again, what we do here is we use scikit-learn, and we do a grid sweep. If you wanted to, you could actually do the grid sweep using Spark sklearn, and record the details from the individual training iterations on a Spark cluster. I'm gonna go through this pretty fast. And what we do here is that, again, we take the model in this cell number 7, and we save it as a pickle file. And here we see some more results of our. We did some hyperparameter tuning. So here we see a display of the different parameter values of my. This is I think this is using gradient boosted tree model. We see the best model found for the different combinations of parameters. And if I wanted to, I could actually save this visualization as part of my run history. And we can also look at the feature importance, and if we wanted to, we can include this in the run history. So then we come to the final part of this example, which is that, let's say we are happy with this train model again. We want to deploy it as a web service to production. And how do we do this? We create this little piece of code shown in this cell number 8, where we have two functions: init, which loads the model we want to use, and a run, which basically calls the model.predict to make a prediction. And then what we do here is we use the cell magic write file to write this into a score.py file, and this is then something that we can now deploy alongside with our model into production as a container. So of course it's a good idea to try these init and run functions first, and then we do something. There's one thing we want to do beforehand, which is actually quite useful, which is we can create a schema for our web service by calling this generate schema API and passing it one sample of my data. It basically creates a Swagger description for this web service, to which I can now pass incoming data and get predictions from. And then finally we deploy this web service. So we use commands from our command line interface embedded as a shell commands into our notebook. AZML service create real time. We pass it the scoring program. We pass it the model. We pass it the schema, and we pass it the dependencies of this particular project. It goes ahead, spins up a cluster on the Kubernetes cluster as a Kubernetes as a container service currently, as a Kubernetes service in near future, and that takes care of the routing, load balancing, elasticity of the endpoint. And now we can test this web service, see that it's working, and that's how it's done. So to summarize, I showed you in examples how you can use Jupyter notebooks on Azure Cloud, through Azure Notebooks, through the Data Science VM, and on HD Insight Spark. And I also showed you examples how you can manage your project, manage your notebook runs through the Azure Machine Learning services, and how you can deploy models to production through those services. So that covers what I had to present today. Looks like we beat the snowstorm. So thank you for your time and attention, and time for questions.